Welcome everyone. We're happy that we're all together again. In this tutorial, we will start on designing the return air system for the zones that we have inside the second floor. So if we go to the first zone, we will find that we have that VAV box that controls the airflow through it, and that VAV box has an output and it has an input. So this input for the input supplying air and this output for the output supplying air, and this input is going for the return air, not the supplying air. So what we will do now is to go out of that VAV box with a duct, and this duct will be connected to the return diffusers for that space and for the other spaces in that zone. But the problem that will face us is that when we go out of that VAV box with a duct, this return duct will have the same offset of that supplying duct. So if there is an intersection between the supplying duct and the return duct, they will have the same offset and then they will interfere together. And for that purpose, we need to make the usual trick, which is to increase or decrease the offset of the return duct. So if we change it, the offset of the return duct generally, we will have no problem as it will not interface anyway with the supplying duct. And the plan that we have now for routing the return duct is to go out of the VAV box with a duct at that direction, then we go at that direction here, and then we go forward at that direction to feed all the spaces that we have. But the problem that will face us here is that this forward distance may be a narrow distance for the return duct to go through it, and for that we need to shift the position of that diffuser and that one. So we can select the diffuser and then press on a line, and then we save the project, and we align that line here with that edge of the diffuser. Very good. We do the same thing for that line here, and we align it with that edge of the diffuser. Now we will insert the return duct, and for that we select that VAV box and press on that tab to insert the duct, and we will insert it until that position only. So until that position, you can see the duct has an offset of 3150 millimeter, which is the same offset of that duct, which is 3150 millimeter. So what we will do now is to select that return duct and then press right click and then draw duct. But for the duct that we will draw now, we will increase its offset so we can make it to be 3550 millimeter instead of 3150 millimeter. Now we can go onto that position here and then we go there. So let's go forward to that position, but you can see we cannot draw a duct at that position. This is because this duct is very near to that main duct or that duct that is going out of the air handling unit. So we can press on escape and then escape another time. And then a good solution is to select that VAV box and we can shift it left here by pressing on the left arrow on the keyboard. So we can shift it to that position and then we can decrease the length of that duct. So we can drag it left here and then we can select those ducts and then we can press remove and start moving them from that point and then we connect them to that point. More than great. Now we do the same thing. We press right click and then draw a duct. And let's draw the duct to that position. You can see we can draw the duct now. We have no problem. This is because the offset between that return duct and that air handling unit duct is sufficient now to draw the return duct. So we can draw it easily at that position. And then we can go there. Here we can go forward to insert the duct until the last space that we have, as the return duct or the main return duct will enter all the spaces to absorb the air out of all the return diffusers that we have. Also, the second note is that we can distinguish easily between the return duct and the supplying duct with their color. So the supplying duct are in blue and the return ducts are on the cyan color. Now to express that we have just done and to see the coordination between the supplying ducts and the return ducts to ensure that we have no problem or no interference between the supplying and the return ducts, we can access that section easily by pressing double tap on it. And here we go. You can see we have a sufficient offset generally between the return duct and the supplying duct. And for that, the return duct can go at any way through these spaces and there will be no interference between it and the supplying duct, as we have increased the offset of it to have a free space between it and the supplying ducts. Very good. Now we close that section. Alright, now what we need to do is to design the return air system for that first space, and it will have the same idea for the supplying air system, so we will have the same number of diffusers with the same airflow. So we have here 4 diffusers, and each of them is rated 200 liters per second, so we can insert another diffuser, we press on the air terminal, and then the little thing that will be changing is that, and instead of the supplying diffuser, we will choose the return diffuser. So we press on the return one, and now we change its offset to P 2600 millimeter, and then we insert it at that position, and after that we can select it and press and copy, and start copying it from that point, for example, and insert another one at that position, and also a third one, we copy it here from that point, and we insert it at that position. And finally, a fourth one, we select that one and copy it, and we pick it from that point, and we can insert it at that position. Now you can see we may have an interference between the VAV box and the air terminal that we have, so we can select that VAV box and shift it up a little bit. Very good. Now what we will do is to align the air terminals that we have with the slabs or with the square slabs. So we select that air terminal, for example, and then we press on align, and then align it with that line, here that edge, and then that edge with that line, and also the same thing for that one, and here that one with that edge, and that fourth one we align it also, and that edge with that edge, and the same thing for that fourth one, here that one with that edge. More than great. Now after aligning the air terminals that we have, let's go to the routing operation. So we go to the system tab, and then duct, and start making the duct from that point to that point, and then another one here from that point to that point, and a third one here from that point to the center of the air terminal, and another one here from that point to the center of the air terminal. Very good. You can see we have created the return air system in addition to the supplying air system, and we distinguish between them easily. The return air system has some air terminals and some ducts with the cyan color, but for the supplying one, they are in blue. Now we do the same thing for the second space. Here it needs 3 return air terminals, and if we select that one, we find that it's 200 liters per second, so it needs 3 return air terminals. Each of them is rated 200 liters per second. And for that, we select that air terminal, and we press and copy, and we start copying it from that point, and let's insert it at that point, and then we insert another one, so we press and copy it from that point, and let's insert it at that point. And also a third one, we press and copy it from that point, and we insert it at that point. Very good. Now what we will do is to connect the air terminals as usual with the return duct. So we press and duct, and then we start from that point to that point, and the same thing, we go out of the main duct with another duct, and till that point, and it's connected to the air terminal. And finally, another branched duct from that point to that point. So that's about the second space that we have for the return air system. Now let's move to the third space. Here it requires 2 air terminals, and if we select each one of them, we will find that they are rated 235 liters per second. And for that, we select that air terminal and press and copy, and start copying it from that point, and then let's insert it at that position, for example, and then another one, we copy it from that point, and we insert it at that position. But it will be a good idea to increase their offset a little bit, so we select that one and press Control and that one, and press on align, and align them with that line, hit that one, and also the same thing, we select that line and that one. Very good. This is a good position for the 2 return air terminals. Then we go to the system and duct, and start from that point till that point, and the same thing from that point till that point. So let's apply the return air system for that space. And then if we select the two air terminals, we will find that their airflow is exactly 235 liters per second. But if we select the rest of the air terminals, we find that their airflow is 235 liters per second. So we have a mistake here. We forgot to change the air terminals for the return ducts. And for that, we will select all of the return ducts. As for those two spaces, the airflow, as we said, is 200 liters per second only. So we select all of them. And finally that one, and change their airflow to be only 200 liters per second, exactly as the supply system airflow. So by that way, we managed to design the return airflow for those spaces, and we can see what we have done in the 3D form to imagine it well. So we can select all of that and press on the selection box, and then let's drag it here. So we have the return ducts and the supplying ducts. Now let's go to the first space, for example. Here, this is what we said. We have the return ducts air system with a higher offset than the supply air system. So if we go there, we will find that exactly this duct has a lower offset than that duct. And by that way, we can make the routing operation with no interference between the supplying duct and the return duct. If we increase the offset for the interference position, or we increase the offset for the return ducts generally to overcome the intersecting condition. So let's about this tutorial. Basically, as in the previous tutorial, we ended with constructing the return duct system for those three spaces here, that first space and that second one and the third one. And now let's start with the fourth space that we have to construct its return air system. So if we see it needs 3 air terminals, and if we specify any one of them, we will find that its required airflow. Here, if we drag the tab, the required airflow is 230 liters per second, and for that we will use other 3 air terminals, but of the return type, and each of them is rated 230 liters per second. And I have a good idea of how the design, which is that we can put the 3 return diffusers at those positions here to be in the front of the supplying diffusers. But at first, let's do a little beauty thing, which is to drag the duct right here. So if I select the duct and I press on the right arrow, I'm dragging it right here. And also we can shift those 3 diffusers right. So if I go to the modify tab and I press on a line, then I can align that edge of the diffuser to that line, for example. So I press on that line and then that edge. And the same thing here, I press on that line and that edge, and also that line and that edge. Very good. Now we can put the return diffusers at that space. So I press the double escape, and then I can select that air terminal or that return air terminal, and then copy. We start copying it from that point, and we insert it at that point, and then we copy it also from that point. Let's paste it here, and the same thing. We copy it from that point and we paste it here. More than great. Now what we will do is to extend a branched duct from that main duct here. So we go to the system tab and then duct, and we can extend it from that point here up there until that point. Very good. Now we can do the same thing. Another duct from that point to that point, and a third one from that point to that point. So it's about the return system for that space, and also we can select those air terminals, and then we can change their airflow to be only 230 liters per second as the supplying system, and that's it. Now let's move to the fourth space. Here we will do the same thing exactly as what we did on the third space. So we can drag the duct right here by pressing on the right arrow on the keyboard, and then we align those 3 diffusers with that line, for example. So we go to the align tab and then align those 3 diffusers with that line, for example. So we press on that line and that edge of the diffuser, and the same line and that edge, and also the same line and that edge of the diffuser. Very good. Now we are ready to make the return system by the same way. But at first, let's extend the duct a little bit. So we extend its length, and then we copy them. So we select the diffusers and the duct, and then we press and copy and start copying them from that point, and we can paste them at that point here. Very good. We have designed now the return air system for that space very easily by only the copy and the paste command. Also, we need to check the airflow required for those air terminals. And if I select that supply one, we find that it needs 235. So we will select those three return diffusers and change their airflow to P 235 instead of 230. Very good. Now what is remaining for us is only the last space, so it's a very simple design. It needs only one diffuser that is rated 235, and for that I'll select that one and I press and copy and start picking it from that point, and I can paste it here easily, and then I'll extend the dot, so I press right click and then draw that, and let's start moving until that point and then until that point. So that's about the return air system for that space or for that launch room. And by that way, we have ended constructing the supply and the return air system for the first zone. And on the next tutorial, we will start with the return air cut for the second zone. And this tutorial, we will continue our design of the return air system for the third zone that we have to finish it. So on the previous tutorial, we have finished the designing process of those two spaces, and now let's continue with the rest of the spaces, which only those two spaces, this administration room and this open space area. And if we start with that administration room, we will find that it as usual needs two air terminals, and each of them is rated 250 liters per second. And for that, we will select the diffuser and press and copy. So we pick it from that point, and let's insert it here, and then another one. So we press and copy again and copy that one from that point, and let's insert it here. Now we go to the dock system and save the project, and then we start from that point and connect it to that diffuser, and another one from that point to that diffuser. Very good. Now we change the airflow, so we select both of them and change it to P 215, and that's it. Now the last space we have is that open office. So if we need to go out of that VAV box with a main duct that is going forward to feed that open space, one strategy is that we go up here and then we move to the left. But as usual, we will face that supplying air duct, and for that we will do the same trick, which is to reduce the offset of the return duct at that area only to overcome that supplying air duct. So let's do that plan. Here we press in duct and start from that point. Then we go there until that point, and then we end at that point, and then we decrease the offset to be only 2,750 liters per second, and then we go until that point here we overcome the supplying air duct, and then we increase the offset again, so we make the offset at 3,150 millimeter, and then we can go until that point here. Very good. Now we press escape, and let's shift the depth a little bit down here. Now not to confuse ourselves, let's drag the tag up here, and then we will insert our return air terminals. So I select the air terminal, and then I press and copy, and start copying it from that point, and then I can paste it at that position, and also another one, we select it and press and copy, and I start picking it from that point, and I insert it at that position, and another one, so we can take that one and press and copy and select it from that point, and let's insert it at that position. For example, as you see, we need 5 return air terminals to be equal to the 5 supplying air terminals. Here, 1, 2, 3, 4, 5. So we have inserted 1, 2, 3. We need other 2 air terminals, and for that we press and copy again and select it from that point, and let's paste it at that position. So those are 4 air terminals, and we need the last one. So we can copy that one again, press and copy, and select it from that position, and we end at that point here. So let's insert it at that position. More than great. Now let's start the routing operation. So I'll press on the system and then duct, and then we start from that point, and at that point, and another one from that point to that point, and we need a third duct, so we start from that point, for example, and go there, and then we go there until that point, And then we end at that point. Very good. Now the last diffuser we have is that one. So we go from that point here onto that point. Very good. Now we have that last diffuser. Then we draw another dot, so we press on dot and start from that point until that point. Very good. Now we can decrease the extension of that dot. So we don't need some useless extensions of the dot, so we can drag it right here and then press on cap open ins to cap it. Very good. Here that's the return air system. And what we will do now is to change the airflow setting for each of them to be exactly as the supply airflow. So for that supply duct, we need 195, and for that we select that return duct and press on control and select the second one, the third one, the fourth one, and finally the fifth one. And then we change them from 2015 to 195, and that's it. So that's about the final zoom that we have for the return air supplying system. And also we can check it in the 3D form. So if I select the zoom here, and then I press on the selection box, you can see this is our system for the supply, and for the return ducts, this is the input duct that is going forward from the main duct from the air handling unit. If you remember, it's going with the supplying air, and then we have that return air duct. So this is the return air duct that we have just created from the previous tutorial, and this is a branch from it, and this is the trick that we have made, which is to change the offset of the return duct to overcome the interference with the supplying duct. And then we go there with that return duct to feed the third terminal and that second one. And here if we go there a little bit, we find that we have also that branch duct to feed those featured air terminals. But for the supplying air terminals, we have that one and that second one, that third one, that fourth one, and that fifth one for that space. And those are terminals for the second space, and those one for the third space, and those one for the last space. So that's about this tutorial at which we have finished the return air system ducts, and we have completed our view for the supplying system and for the return system for that floor. Hope that's clear. In this tutorial we will start the designing process for the rest of the floors that we have. As in the previous tutorial, we have finished the designing of the supply and the return air system for the second floor, and now let's jump to the first floor to make the design for it. As you see, for the first floor, it has a near structure that is very near to the second floor on the spaces that we have and on the zones also. So we have the same three sections, but there are some little changes in the distribution of the rooms or their architectural design. So the rooms are a little bit different from the second floor. And for that large similarity between the two floors of the second floor and the first floor, we can do something that will facilitate the designing operation greatly. So what we will do is to copy all of the earth system design from the second floor, and we will paste it on the first floor. And then we will make the required modification on the design for each space. For example, if we go to the second floor, we will find that that space, which is that instruction room, requires 4 terminals, and each of them is rated here as you see 235 liters per second. Now if we go to the first floor for the same space, we will find that it's another instruction room, and it may have a different area from the previous room, which is aligned at the same position for the second floor. And for that we may have a different number of air terminals, or we may need the same air terminal design but with a different airflow through each of them. So what we wanted to say is that it's very easy to copy all the air system from the second floor and to align it at the first floor and make the required modification. This will be more easier than if we go to this first floor with its supplying design and start making the air system design from very beginning and from the very scratch of each element. So this will be a tiring operation. And for that we go to the second floor, and then we can select the whole of the design. So I can select all of the floor, and then I press on the filter tab and we check none. Now what we need is the air terminals, the ducts fitting, the ducts, and finally the mechanical equipment. So those are the air system equipments that we need, and then we press on apply, and then we press on OK. Now we go to the copy tab, and then we go to the first floor. After that we go to paste and align to the current view. And then it asks us if we need to save the project. So let's save it. Very good. As you see, this is the air system design that we have just aligned. And surely it needs some modifications. For example, this area for the second floor was only one space, but here it's split into two spaces. And for that, you can see the diffuser is going at the position of the wall. So this system needs totally some changes, and we must make those changes. But at first, let's go to the entry level and do the same thing also, as it has also a similar structure. So we go to it and then go to the modify tab and paste and align to the current view. So by that way, we are pasting the same design from the second floor to the entry level as we did on the first floor. Very good. As you see, this is the design also for the entry level floor. And now we will modify the ducts and the air terminal design to be suitable for each space inside each of those two floors, the entry level and the first floor. But you know, we have learned before many times how to design the duct system, and I'll not repeat those steps again not to waste your time. But I'll take only a sample for a room and I'll modify it for you to know how the modification operation can be done. For example, if we zoom in, we will find that we have here a cafeteria, and this cafeteria has a different structure for its ceiling. So it's suspended ceiling square slabs go with a declination angle. As you see here, it goes with that angle, while the slabs for the other rows are going vertically, as you see. So we will align the diffusers that we have, or that air system, with those declined square slabs, not to be vertically as the traditional design for each space or for the other spaces that we have. Now let's try doing so. Here we zoom in, and then you can see this cafeteria needs a total airflow to be 1486. So if we suppose that this cafeteria will be fed with 6 diffusers, here we need to calculate the airflow for each diffuser, and for that we can go to the calculator. And now let's make the modification operation. So we can select the duct and we delete it, and let's select the diffuser, and here we will align it with that slab, for example. So we go to the align tab and select that line and then that edge, and then we select that line and that edge, and then that line and that edge. Very good. Then we can put another one. So we can copy that one. We press and copy and we pick it from that point. And then we can paste it at that position. So let's about the second one. And now for the third one, here at first, let's delete those return dots. So we delete them now. Here we select them and we delete them. Very good. Now let's delete those air terminals also. We delete them. And then that one we delete it, and that one, and that one, and also we delete those ones, and that one, and also that one, and here delete those dots. Very good, it's more clear now. Here we select that air terminal and press and copy, and we pick it from that point, and let's paste it here at that point, and then we can copy it another time and pick it from that point, and we paste it at that position. Then the third one, we press and copy it from that point, and we paste it at that point. So if we count them, we find that 1, 2, 3, 4, 5. So we need the last one. We press and copy and pick it from that point, and it will be a good idea to insert it here. Now what we will do is to connect these supply ducts with those supplying air terminals. So we go to the System tab and press a duct, and then we start from that point, for example, and we go until that point, and then we make the routing operation to that air terminal. Now we make another duct. We can start from that point, and we go there until that point here, and then we make it until that point. Very good. Now we can delete that duct, and that tab we delete it. And then for the third air terminal, we go to the duct system and start making it from that point here until that point. Very good. Here we have connected the third air terminal. And for the fourth air terminal, we do the same thing. We go to the duct tab and start it from that point until that point. More than great. Now for the fifth diffuser, we do the same thing. We go from that point, for example, and we go there until that point to that air terminal. And finally, we have that final air terminal, but before making the routing operation for it, we can delete those return ducts as we don't need them now. Here we select that one and delete it, and that one, and delete it also, and then we go to the duct system and start from that point and go there until that point, and then up. Very good. So that's about the supplying air system for that cafeteria. And then we delete that air terminal also. We don't need it. And finally, we change the airflow for each air terminal we have. So we select that one and that second one and then that third one and that fourth one, the fifth and the sixth, and make them to be 250 liters per second. And the final thing we need to do is to connect the return air terminal system. So what we will do now is to delete those ducts. We don't need them. And then we can align that air terminal here with that slab, for example. So we press on align and then that edge with that air terminal edge. Here that one, and then the decline edge with that decline edge of the air terminal. And we will delete that air terminal. We don't need it. And then copy that one. So we press on copy and start picking it from that point, and then we paste it at that point, and then we select that one again and press and copy, and we pick it from that point, and then we can insert it at that position, and also we can copy it. We press and copy again and copy it from that point, and we can insert it at that position, and another one, copy from that point and insert it at that position. So let's zoom in, and here we insert it at that position. Very good. So that's about the supplying and the return air terminals, but it will be a good idea if we drag that one a little bit up. So we press on the line and align that edge with that edge. More than great. So we have here 5 air terminals, 1, 2, 3, 4, 5. We need the last one, so we can copy that one again, press and copy and select that edge, and we can paste it at that position. Very good. Now for the routing operation for those return ducts, we can go easily to the system tab and press on duct and start from that point and go up here until that point, and then we go to the second one. So we start from that point and go up here until that point, and then we make a third one from that point, and here we go until it. And for the third one, we need another duct that is going up here and go forward, so we can make a branched duct from that point that is going up, and then we go there a little bit. And then let's move also a little bit forward. And now let's decrease the offset of that duct to overcome the supplying duct. So we need no interference between the return duct system and the supplying duct system. So we make it to be here to 700 and go until that point here. But as you see, we will face that diffuser. So we can press on escape, and then we select the duct and press on the down arrow on the keyboard. So we are decreasing the height of the duct not to make any problem with the air terminal system. And then we go again and insert another duct, but at that point we will make it back, or we will return it back to its original offset, which is 3150 millimeter. And then we go to the duct again and we insert the duct from that point, but at that position we will increase its offset again to return back to 3150 millimeter. And now let's move forward until that point, and then we go to that return air terminal. Very good. Now we can take a branch duct that is going here and it's going forward to that air terminal, and another branch duct that is going here and it's going forward to that air terminal. So we can go there from that point and go forward here until that point, and then we connect it to that air terminal, and then another one that is connected from that point to that point. More than great. Here we have connected the return air terminals and the supplying air terminals. But a problem that you may face is that the return air terminal now has the same color of the supplying air terminals. This is the return one, for example, and its color is blue. And this is a supplying one and its color is blue. So this problem may appear if if we make the routing operation for the return air terminal with a supplying that air terminal. For example, if I select the ducts and I go to the superburst, you will find that it's of the supply type, and this is a mistake. And for that, we will change it to be a return one, not a supplying one. And here we go. You can see its color has been changed, and also we select that one, and we select that one, and the third one, and then we go to the type. There are the supplying air. This is a mistake. We make them to P of the return air. Very good. You can see all the return air systems has been turned back to its original type, which is the return air. And for that, we can distinguish between the supplying air system, like those air terminals, and the return air system for those return air terminals. So let's about this tutorial at which we have made the modification operation for one space, and I'll do the rest of the required modification operation myself. And for you, it will be easy now to make the modification for your system, as we have learned many times how can we make the air system, and we have faced many problems, so you can go forward and do well now. In the previous tutorial, we have modified the air system only for one space, which is that space here or that cafeteria. But as I told you, I have prepared the modified air system, liquid air terminals and ducts, and you can enjoy exploring them to see all the differences and the design. So I have the job for the entry level floor and for the first floor. And now after finishing all the designs that we have for the supplying and the return air system, we need now to make some checks or to ensure that there is no problem in our design. So the first thing we need to do is to check that there is no open ducts or no ducts that is not connected to the air terminals by mistake, for example. And let's do that operation on the second floor. Here for the second floor, we go to the Analyze tab, and then we press on Show Disconnects. And here it asks us for the components that we need to check it, if there are some disconnects or not. If we need to check the disconnects for the ducts or for the pipes, for the cable tray and conduit for the electrical equipments, but for us, we will check the ducts as we are making the duct system now, and then we press on OK. Very good. Here you can see the open ducts has those yellow signs, so if we go there, we will find that we have this yellow rectangle, which means that we have here an open end. So if we zoom in, we can find that this is a problem, as we have shifted by mistake the VAV box, so it was shifted from the output duct, or they are not connected to each other. And for that, what we will do easily is to go to the Modify tab and then align, and we will align that line here to that line. And by that way, we can connect the two parts together. So to solve that problem, we can easily select those ducts here, and then we can delete them, and then we make the routing operation another time. So we select the duct out of the VAV box, and then we press right click on that tab, and then draw duct, and then we draw duct onto that point to connect them together. Very good. And you can see the yellow triangle sign has disappeared, which means that we have managed exactly to connect that part together, or there is no disconnect between the VAV box and the elbow. Now we need to do the same thing with the ducts here that are connected to the main duct. So what we will do now is to select all of those ducts, and then we delete them. And after that, we select the duct and press right click and draw duct. And then we go here until the middle of the central duct or the main duct out of the air handling unit. And then we go there. Very good. Here we have connected that one. And then for the second duct, we select it and press the right click and draw duct. And then we can go there and zoom in until the first line or until the surface of the air handling unit main duct. And that's it. You can see we have connected also the second duct with no problem. So the disconnection sign has disappeared from that duct and from that second one. Now we will do the same thing for the third duct. Here we select it and right click and draw duct and go until the center also, and then go there, and then we zoom in until the surface of the main duct. Very good. You can see also the third duct has been connected easily, and there is no disconnection point between the third duct and that main duct. Alright, now if we go there to scan the rest of the drawing, we can see we have here a disconnection. So we have forgot to connect that main duct with that air terminal, and for that we go to the system tab, and then we press on duct, And then we start the connection point from that point until that point here. But at first we need to change the offset, so we will set the offset back to the original offset 3150 millimeter, and then we connect it to the point. Very good. Here we have connected our duct exactly as we need, and then we go there to scan the rest of the project. So we have no problem or we have no disconnection at that point. Also, the second check we need to perform is the interference check to ensure that there is no ducts that are interfered with each other. And for that, we go to the Collaborate tab and then press on Interference check and then run interference check, and then it asks us for the components that we need to make the interference check for it. So the most important thing for us now is the duct, so we select the duct here and that one, and then we press on OK, and here it's loading. Now it tells us that the interference that we have are in that duct and that duct and that one and that one and that fifth one and that fourth one. So if we select any one of them and then we press on show, here it gives us the duct that has the interference. So this is the duct that has an interference, and correct that interference. Also we can check that second one and press on show. Here it tells us that this is the second duct that has the interference, but you can see those ducts are on the first floor, not the second floor. Here we go to the third one and then press and show for the fifth one and the sixth one are the same way. Now we can press on close and go into the third floor. Alright, now after checking the system, we need to start the sizing process of the ducts. But the problem now is that if we need to make the sizing process directly, for example, for that duct, so the program will consider that duct here to be only one duct, and for that it will give it only one size. But this is a problem here, because the airflow that will go out of that duct at this position will be higher than the airflow that will go through the duct for that position or for that particular part. This is because the airflow for that part is the total airflow for the system, but the airflow of that part here is the total airflow minus the airflow for that branch. And also the same thing, if we are talking about the airflow for the final part of that duct, for example, it will be smaller than the airflow of the first part. This is because the airflow of that part is only the airflow that will go through that diffuser, while the airflow for the first part and the total airflow that is going through that branch and that second one and that third one and that fourth one and so on. So what we want to say is that although we have one duct only, but this duct must be sectionalized into some sections, and each section of them will have some different dimensions according to the airflow through it, according to the sections that this duct or this part of the duct will feed. And this means we need the size of that part, for example, of the duct, to be larger than the size of the rest of the parts of that duct. So the part size will be larger than those parts size. And to solve that problem, we will split each part of the duct at which we have a different airflow. So we will split that part from that part, and we will split that part from that part, and we will split that part from that part, and so on. And to do so, as we learned it before, we go to the Modify tab, and then we press on Split, and then we save the project. So we go to that point, and we split the duct, as that part of the duct will have the total airflow that is going through all the spaces at the zone. And then we go to that part and we split the duct, and then we go here onto that part and we split the duct also. And the same thing at that part, we split the ducts, and here we go there until that point and we split the ducts. Now what we will do is to select that part of the duct and press on tab. So press on tab another time, so the total duct has been selected. Now we press a left click. Very good, here we have selected the whole of the duct, and then we press on duct pipe sizing. And now, as we used before, we will use the equal friction method, and we will set the friction losses to P as the default value of 0.82, and then we press on OK. Very good. You can see here we have did it. That part has the larger size because it will have the largest airflow, and that part a smaller size, and that part a less smaller size. And you can see we have here a generated duct fitting because this duct fitting connects a larger size duct to a smaller size duct, and here a smaller size duct, and here the last one is the smallest one because it will feed only that air terminal. Very good. Now we will apply that idea on all of the ducts that we have. So we go again to the split command, and then we go here and split at that point, and then we go there and split at that point, and then we split at that point also, and there we split at that point, and after that we split here and we split there. And we go here and we make a split here and another split there, and we go forward also, so we have no other dots. Now we press on escape and another escape, and then we select any air terminal like that one for example, and then we press on tab and tab, and then we press a left click, and then we go to the depth pipe sizing, and here we will use the same equal fraction method and press on OK. Very good, you can see we have managed to do that. Here the duct for example has a smaller size, and that duct has a smaller size, and you can see the duct has a larger size than that duct because the airflow through that duct is the total airflow for those four air terminals or for those diffusers, while that duct carry only the airflow through that diffuser and that second one. Also, if we go there, we will find that that duct has the largest size. This is a smaller one. This is the least one or the least size. And for that one, we have a smaller size and the least size. And the same thing here, a small size, a smaller one, and the least one. So what we did here on that zone will be applied on the rest of the zones we have, that second zone and the third zone, but not to waste your time. I'll do that myself, and you can enjoy exploring that operation later, or you can enjoy doing it yourself. So let's about this tutorial, and on the next tutorial we will continue illustrating the rest of the designing steps to finish it. And this tutorial we will continue illustrating the required steps to finish our air system layout. Now if we need to analyze the airflow through our system or the pressure losses, we can select the duct system that we have. So if I go to any duct like that one for example and press on tab and another tab and then press on left click, then we press on system inspector, and then we start the inspection operation. So you can see it tells us that we have here the airflow through that duct to P 3500 liter per second, and the static pressure is 728.6 Pascal, and the pressure losses is 621 Pascal. Now if we go there to that duct for example, here for that duct you can see the airflow decreases and the static pressure also decreases and the pressure losses decreases. And for that duct you can see we have a lower values or a total airflow of 800 liter per second and a static pressure of 407 Pascal and so on. And for that duct, so we can see the airflow is only 400 liter per second. This is because that air terminal has 200 liter per second and that one has 200 liter per second and so on. So you can use that powerful operation to analyze or to see the airflow and the static pressure through each duct you have. So those are the direction of the flow through our system, and that's it. Now we press on cancel. And we use those values to choose the required VAV box fan that will push the air inside the ducts that we have. Also, we have another very important tool to analyze the airflow inside our system. So if we go to the second floor, for example, as this tool is applied only on the floors, not the ceilings, and then we can select the duct, for example, and press on tab, and then another tab, and select all the ducts that we have, and then we go to the Analyze tab, and then you can see we have here the duct legend. So if we press on the duct legend, and then we save the project. Now it asks us for the place that we need to insert the duct legend at X, so we can insert it at that position, for example. And then it asks us for the type of the legend. We need it to be according to the airflow or according to the velocity through the duct. So we can make a colored legend or a color table consists of the corresponding airflow of the ducts or the corresponding velocity of the ducts. So each value of the airflow will have its corresponding color, or each value of the velocity will have its corresponding color. So we can set it to P according to the airflow, and then we press OK, and that's it. Very good. Here you can see the program gives us the legend here or the table as we have each value of the airflow through the duct and its corresponding color. So the airflow to be 130 liters per second has the red color, the airflow of 150 liters per second has the orange color, and the green color has 170 liters per second, and so on until the last one, or until the largest airflow we have, which is 3,500 liters per second. So this is the maximum airflow through the largest duct we have, and it has the magenta color. Now if we go there to check that on the layout, you can see we have each duct and the airflow through that duct. So if we go there, you can see those are the different colors, and each color has its corresponding airflow through it. And this is a powerful tool that enables us to know the different airflow values through the ducts only by its vision. So from the vision only, we can see the airflow through each duct. Also, we can change the setting of that duct legend. So if I select the duct legend, for example, and then I press on Edit Scheme, as we said before, we make the illusion according to the airflow, and we are making it according to each value. So each value has a specific corresponding color, but we can make it according to the range. So we can give each range of airflow a specific color. Suppose that the range from 100 to 200 liters per second, we can give it the color to be the blue, for example, and so on. So this is up to you. This is the schematic. You can set the values that you need. So I can deselect that value, for example. I can add another value that I need to enter, and so on. Now we press on cancel, and at that point what we need to do to finish our drawing is to add the required information that enables us to construct the project at the real site. And for that, we will press on Ctrl Z to return back. As we don't need those colors now, we press on Ctrl Z. And then as our need is to make the construction engineer to read the drawing and know what are the dimensions of the ducts that we have, and for example the offset of each duct from the floor level and its type to be a supply one or a return duct. So for that purpose we can tag the ducts that we have from the Annotate tab. So if I go to the Annotate tab and then I press on Tag All, so it asks us for the elements that we need to tag, and for that we need to tag the ducts. So we press on the ducts and then include elements from the linked files, and after that we press on OK. Very good. You can see here we have each duct dimension. This duct, for example, is 700 by 700, and this duct is 650 by 650 millimeter. But you can see the ducts tag are very confusing and their size is large. So if I select one of them and then I go to Super Parts, and then I go to Edit Family. Now I can change each duct size. So if I select that size, and then we go to Separate Parts, and then Edit Type, and here for the text size, I can make it to be only 1 millimeter instead of 2.5 millimeter. And then we press on Apply, and OK. And then we are loading the project. After that, we override the existing version. Very good. That's more pretty and clear as we have decreased the duct dimension. So this is the idea. We need the layout to be an informative one as much as possible. Now, after adding the dimensions through each duct we have inside our drawing, what we need to do now is to add some dimensions that tells us what is the position of each duct with respect to the walls we have. So I make a sample now for those dimensions, not to waste your time, but I'll complete the rest of the layout later. And for that, I go to the dimension command. So let's start making the dimension from that point, for example. So that point, and also we can make another one here from that point to that point, and then a third one from that point to that point. Very good. Now another one from that air terminal, for example, to the end of the wall. Alright, so by that way you can make the dimensions so that we have for the drawing. And also we forgot to do a very important thing, which is to add the offset of the duct and its top elevation on the tagging process. So if I select the tag, and then I go to Edit Family. Now I go to Edit Size, and then select Edit Label. And here we have its size only, but we need also to add the top elevation. So I'll search for top elevation. That's good. We select it by a double click. After that, we need to express that is a supplying one or a return one. So for that, we select the system type and press a double click on it. And then we press on apply and OK. And that's it. Now we press on load into project and then override the existing version. Very good. You can see here we have the depth dimensions and its elevation to be 3,250 millimeter and its type to be a return in1 and the same thing for the rest of the depths that we have. So we are making our layout a more informative one as much as possible to make the required constructing process on the real site. So that's about this tutorial, and on the next tutorial we will continue the rest of our design. This is the drawing of the entry-level ceiling after adding all the required details of the duct's dimensions and the vertical offset from the floor. You can explore it. We have added many details and dimensions on it to make it an informative one for it to be ready to be put in its final form. So what we need now is to put the drawing in its final form or its final template. And for that we can handle its scale firstly. So we need to decrease its scale, and for that we go to the scale level and we can make it to be 1 to 200 instead of 1 to 100 as its default value to be 1 to 100, but we will make it now to be 1 to 200. Very good. You can see here the drawing has been decreased, or the drawing scale has been decreased, but the problem now is that the tag itself or the spaces tags are with its same scale, so we need to decrease its scale to the half as we have decreased the drawing to its half scale. So we select it and press on Edit Family, and then select it and press on Edit Type. And then we will make the text file to PDF, which is 1.5 instead of 3. And then press Apply. You can see the text size has been decreased. Now we press on Load into Project and then override the existing version. Also, we need to do the same thing with the dimension scale. So we can select the dimension and then Edit Type. And now we go down. Here we are searching for the text size. So that's the text size. It's 2.5. We will decrease it to be 1.25 and then apply. And then OK. Very good. Also, the dimensions has been decreased here. So it's circle for the drawing scale that we have decreased. And now the final thing we need to decrease its scale is the duct tag. So if I select the duct tag, you can see it has a larger size. So we go to Edit Family and then we select it and go to Edit Type. And then for the text size, we will make it to be 0.5 instead of 1. This is to cope with the change in drawing size, and then we press on Apply, and then OK. And after that, we can decrease its width a little bit. Very good. Now we press on Load into Project, and then OK, and override the existing version. More than great. Here we have did all things as we need. So we have decreased all the sizes of all of the drawing to be of its half scale. Now after handling the drawing scale, we need to export the drawing template. So we go to the View tab and then we press on the Sheet option and save the project, and then we will load the A1 matrix size. So we press on OK. Very good. This is the template that we have illustrated before, and those are the information that you need to enter. Now we go to the project browser again, and what we will do easily is to drag the ceiling that we have worked on. So we have worked on the entry-level ceiling, so we select it and drag it easily at that position. Very good. Here we can put it at that position. As you see, this is our final drawing, and it has the scale as we have just set it to be 1 to 200, and those are all the details that we have made here. Those are the dimensions, for example, and the tags of the ducts and the spaces names and so on. Alright, also we can add some sections to the drawing, so we can go to the elevation plan and express some sections with some other details, as it's not sufficient to have the plan view, but we need also to have some sections or some details from the elevation view. And for that we go to the entry-level ceiling again, and then we can make a section. So we go to the section tab and make it from that point to that point, for example. But let's drag it down a little bit. So we select it and drag it here. And then we can decrease its view range. So we can drag its view range down here. Very good. Now we can access it by double click on it. Very good. As you see here, those are the ducts that we have. But let's increase the details level. So we go to the details level and make it to define. So those are the ducts with all of their details and dimensions. And what we can do easily is to go to the dimension command and start making some dimensions to see the vertical height of the ducts with respect to the suspended ceiling surface. So we can start from that point till that point here. That's good. Now let's make another one from that point to that point. Here, that's it. And also we can go there. Here we can measure the distance from the center of that duct to the suspended ceiling surface. That's it. And also another one from that duct here until that point. And let's put it here. Alright, now let's go there a little bit. Here we can measure the distance also from that point to the surface of the air terminal or to the surface of the suspended ceiling as they have the same surface. And that's it. It's about 0.44 meter. And let's go there. Here we can do the same thing from that duct or from that return duct to the surface of the suspended ceiling. Now let's go back to our template. So we press on escape and another escape, and then we minimize that window and go back to the template. So if we go there, we will find that this is the template that we have. We maximize that window and then we go out of it. And then to add the section that we had just created as related before, we find it under the mechanical discipline and then sections. And after that, it's the last section, section 10. We select it and drag it here. Very good. Now we can center it also. More than great. Here, as you see, we have selected our final drawing, which is the plan view, and also we have selected the elevation view with the required details that we have, or we can add all the required details as we need. This is up to you, but what I need you to know only is that this is the idea about the final form of the drawing with many details that you will need for constructing your system on the real side. And now the final thing we need to do is to express the drawing that we have in the 3D form or on a 3D animated form. As we have learned before, we can express the 3D form of the drawing, but also we have another strong tool, which is the walkthrough, that enables us to take a 3D animated tour inside our floor or inside our building to see how our design can be shown in the 3D form with an animated view. And for that, we can go to the entry level ceiling again. Here we drag down to the entry level ceiling, and then let's zoom in. And after that, we press on 3D and walk through. And now it asks us to specify the path at which we need to make that 3D animated tour. So we are specifying some points now, and those points represent that path. So if I press a left click here, you can see we specify the starting point, and then we specify the other steps that we need to make. So I'll press another left click. So that's the second point, and let's zoom in. And I press another left click, so that's the third point. Then I go there and another left click, and then you can see you can change the direction as you need. So you can change the direction and the number of steps. I can add another step by left click and go there and another left click, and also go there and another left click and go forward and another left click and go there and another left click, and here at that point let's turn to the right, so another left click, and then we go there till the third zone. So we are expressing all the zones that we have. Let's turn right also, so we need to express all the zones that we have or all of these spaces, and then another left click, and finally another left click at the end of the floor that we have. More than great. Now what we will do is to press on finish walkthrough, and then to activate the 3D animated form, we press on edit walkthrough, and then we press on open walkthrough. So this is the starting view of our walkthrough. Now you can see we have 300 frames of 300 frames. So those frames are the frames of the video or the 3D animated video that we will perform. And for that, we need to reset it as it goes to its maximum here, but we need to reset it. So we make it to P0 now. And then we go to edit walkthrough again. So you can see we are moving here inside our polling, or those are the dots that we have created before. So that walks through gives you a good imagination of the system that you have made in its 3D form with an animated shape. As you see, those are the dots of the entry level ceiling, and those are the air terminals of the supply type and the return type. And as we are on the entry level, so you can see we have also the first level upper to it, and here we are drafting to the right as we have just made. And those are the dots that we have. And you can see this is the bridge that we have made to overcome the supplying air terminal. And here we are drafting to the right also to go to the third zone that we have. And this is the VAV box. So we are handling now the supply and the return air terminals until going to the last space that we have inside the last zone. Very good. So by that way we have ended the walkthrough, and you can make your own walkthrough as you need. So this is about this tutorial. Hope that's it. This tutorial we will start on designing the chiller system that will feed our air handling unit. As we learned it before in part 1, the chillers can be classified according to the type of the substance that is used to condition the air, and for that we have the water cooled chiller and the air cooled chiller. So for the water cooled chiller, the water is used to cool the water that is going forward inside the air handling unit, and for the air cooled chillers, the air is the source that is used to condition the water that is going directly inside the air handling unit. So the chiller supplies the air handling unit with the cold water, and then the air handling unit supplies the VAV boxes with the required conditioned air through the ducts. So that was a quick revision to refresh your mind. And now let's start inserting the chiller. And for that we will use an air-cooled chiller, not a water-cooled one. And because we have added the air handling unit on the roof of the school, so we will add also the chiller on the roof of the school. And for that we go to the System tab, and then Mechanical Equipment. And after that we will load the family as we need the chiller now. Then we go to the libraries. After that, use metric. Then we choose the mechanical file. So we press on M, that's the mechanical file. And now MEP. After that, the water side component, not the air side component now, as we are going to export the chiller. And this is because the output of the chiller is the water that is going forward through some pipes to the air handling unit. So for that, it's a water side component. And those are some different types of the chillers that we can use. So let's go down. Here we have the rotary type chiller, the screw chiller, and the scroll chiller. So let's choose the chiller here, which is the type M screw chiller, air cooled. And then we press and open. Very good. This is the chiller as you see. And now let's place it at that position, for example. And then we press an escape. And another escape. Now let's explore it closely. So if we zoom in and if we select that chiller, so as you see we have an electrical input here which is used for the electrical supplying power, and also it has an input terminal here for the input water that is going input for it, or for the warm water that is going out of the air handling unit inside the chiller. So this is the input terminal for the backward water that is going back from the air handling unit, and here we have its output, and its output as the cold water or the conditioned water that is going out of it through another pipe, and it will go directly inside the air handling unit. So its input and its output are connected to the air handling unit, and this is because the water is going through a closed cycle from the air handling unit to the chiller, and from the chiller to the air handling unit. Very good. Now if we do the same thing with the air handling unit to check it, and if I select it, you will find that it has an output terminal here that is used for the warm water or the hot water out of it back to the air handling unit, and also it has another input, but to see its input we can make a section. So if I select that section and if I press a double click on it, now let's zoom in and select the air handling unit. So you can see this is its output terminal that is connected to the pipe that is going to the chiller, and this is its input terminal that is connected to the input pipe, and it takes the cold water from the air handling unit. And for that you can see this is a red sign which refers to the warm water, and this is a blue sign which refers to the cold water. Very good. Now we can close this section. And now we need to make the connection of the pipes between the air handling unit and the chiller. But we cannot connect the pipes directly from the chiller to the air handling unit. And this is because we need a pump that will push the water from the chiller. And for that, we need to add a pump between the chiller and the air handling unit. And to select that pump, we go again to the mechanical equipment, and then we press on load family. After that, we go to the light press, then use metric, then the same mechanical file. After that, MEP, and then we go again to the water side component, as the pump is a device that is used to push the water, so it's a water component. And then we select the pumps. Here you can see we have many types of the pumps that we can use. But for us, we will use that pump, which is the paste-mounted one. And then we press on open. Very good. Now we can paste it at that position. For example, here it's at the middle between the chiller and the air handling unit. And then we press a double escape. And also let's explore it for its input and its output. So if I select it, you will see it has an input which is connected to the input pipe for the input water that is going inside it to push it. And it has another terminal for the output which is connected to the pipe that push the water out of the pump. Alright, but for now we will not connect the pipe directly from the chiller to the air handling unit. So what we want to say is that the input pipe for the pump is connected to the output of the chiller or the output pipe of the chiller, and the output pipe of the pump itself is connected to the input pipe of the air handling unit. And for that, we need to make that required routing operation. And for that, we will access the chiller that we have, and we will access its output pipe. But for that, we need to make a section, or we need to make another section. So we go to the section tab, and we start from that point till that point. And then we access that section. And let's zoom in. Now we access the chiller, and then we access its output pipe. So we press here, a right click, and then draw pipe. And now let's go there a little bit, or let's go up a little bit. And then we go forward here until we go to the output of the pump that we have. Until that point, for example, and then we press escape, but let's increase the details level to be fine, and then save the project. Very good. This is the pump that we had just created. Now we connect it to the input of the pump. Here we select the pump, and then we press a right click on its input, and then draw pipe. And that pipe will go until that point, and then we connect it up to be connected to the output pump of the chiller. Very good. Here we have connected the output pipe of the chiller to the input pipe of the pump. Now we will do the inverse of that operation, which is to connect the output of the pump that we have with the input of the air handling unit. So we select the terminal of the pump here and press a right click, and then draw pipe, and let's go up a little bit. Here we go up. After that, we press escape. And now let's end that section. And then you can see this is the pump that we had just created. We select it and then draw a horizontal pipe until that point. This is a good one. And then we go forward here until that point. Now we press on escape. So to make this section, we go to the section command here. And let's start making that section from that point to that point. And then we swap it to change its direction. And also let's increase its view range. Here it's forward view range, we increase it. And then we access that section. Very good. Now we can increase that section also from the upper level here until that point. As you see, this is the pipe that we had just created. But let's at first change the details level so we make it to be fine. Very good. This is the output of the pump, and this is the output pipe from it, and it will be connected to the input of the air handling unit or its input pipe. So that's the input pipe of the air handling unit. We press a right click and then draw pipe. And then we go forward to connect it with that pipe here. Very good. Here we have connected the input of the pump to the output of the chiller, and we have connected also the output of the pump to the input of the air handling unit. Now what we need to do is only to connect the output of the air handling unit to the input of the chiller directly. And for that we can select the air handling unit and then press a right click. and drill pipe, and let's make it to go forward here until that point. Very good. Yeah, let's press on escape, and then we close that section. And after that, we change the details level, so we make the details level to be fine. And then we select the chiller, and we can access that section. So from that section, we need to go out of the chiller with the input pipe. But at first, let's increase the upper limit of that section. So we drag it up here. Now we select the chiller again and press right click and then drill pipe and go here and then go up until that point and connect that pipe to the air handling unit output pipe. Very good. Here, what we did exactly is to connect the output of the chiller directly to the input of the air handling unit, and we connected the input of the chiller or the input pipe as you see here. We connected it with the output of the air handling unit, but we connected it through that element which is a dot pump, as a dot pump will push the water from the chiller to the air handling unit. So to see the full picture, we can increase that section here. As you see, this is the full picture we have, as it represents a complete cycle between the chiller and the air handling unit through the pipes out of them input to the other port. And we can imagine that well in the 3D form. So if I select the port here, and then I press on the selection box, you can see this is our system in the 3D form, but let's increase the details level as usual to be fine. Here you can see this is the pipe that is going forward from the chiller to the air handling unit, and this is the other pipe that is going from the air handling unit to the chiller, but it goes through the pump here, as the pump works as an intermediate between the chiller output pipe and the air handling unit input pipe. So let's about this tutorial, we will continue designing the piping system required for the chiller, the pump, and the air handling unit. As we see in the previous tutorial, we ended with the routing operation between the chiller, the pump, and the air handling unit. So we have connected this closed loop system with the required pipes, and now we need to perform the sizing operation of those pipes. So to make the sizing operation, we can select easily one pipe, and then we press on tab, and here the whole of the pipe has been selected. You can see it's highlighted in blue. Now we press a left click, so the left click to ensure that we have selected that pipe, and then we go to the duct pipe sizing. And here we have two sizing methods, the velocity method and the friction method. So we will set it to be the velocity method. And for that, we need to set the velocity of the water that is going inside the pipe. But if you remember from part 1 of our HVAC course, we said that the water velocity ranges from 2 feet per second till 10 feet per second. But the ideal or the recommended value is to be 5 feet per second. So we need to select it here to be 5 feet per second. But you can see the units here in meters per second for the velocity. So to solve that problem or to change the units that you have, we can press on cancel, and then we go to the manage tab. After that, we select the project units tab, and then we set the project. And here we need to select the module that we need to change its units. So we need to change the units of the piping system, as we are working now on the piping system. And if we go down, we will find that we have the speed as in meter per second. So this is the default value. We can change it. And here instead of meter per second, we will set it to be feet per second, and then OK, and then OK. And after that, we can select our pipe again and press on tab and press a left click to select it, and then we press on duct pipe sizing, and now you can see the default value of the velocity is 4 feet per second, but we can change it to be 5 feet per second, and then we press on OK. Very good. You can see the pipe diameter has been decreased. So if we select it and we go to its properties, here its diameter has been changed automatically to be 50 millimeter or 5 centimeter. Very good. Now we will do the same thing with that second pipe. Here I select it, and then I press on tab and press a left click, and then go to the pipe sizing and make it also to be 5 feet per second and press OK. Very good. We have decreased the size of the pipe also, and then for the rest of the pipe we select it and press on tab and then a left click and the same pipe sizing, and we set it with the same value and press OK. Very good. Here we have sized the whole sizing of the pipes that we have as we need with the required velocity to be 5 feet per second. Now at that point, after making all the required modification operations, we need to add some controlling elements on the pipes to control the water flow through those pipes. So the first element we need to add is a controlling valve that controls the flow of the water through the pipes. So we need to add a valve that works as an on or off controlling valve. As in fact, in some times we need to allow the water to flow through the pipes, and in some other times we need to prevent the water from the moving operation through the pipes. And for that we go to the system tab, and at that time we go to the pipe accessories as the valve lays inside the pipe accessories tab, and then it asks us if we need to add a pipe accessory family. So we press on yes, and then we go to the libraries, use metric, and here we search for the pipes. So that's the pipe, we press on it. After that we select the valves. Now we need a controlling valve, as we said. We need an off or on controlling valve. So we search for the controlling valves. That's it. This is the control valves. We access that folder, and here you can see we have some other types of the controlling valves. So this is the three-way valves that we have talked about on the part 1 of our course. We have the motor control valve and another one with some other dimensions and so on. But for us now, we will select that motor control valve, and we press an open, and then to add it, let's go to the front view. So that's our view. We can zoom in, and then we can go there a little bit. And we need now to put it at the return pipe of the air handling unit, so we can put it at that position. Very good, we have installed our controlling valve successfully. So if I select it, you can see it's a motor control valve, which means that it's a motorized valve which controls its output to be on or off with a motor. But an important required modification now is to change the diameter of that ingoing valve to P as the diameter of that pipe. So if I select that pipe, I see that its diameter is 50 millimeter, and for that we can access our valve. And then we go down to change its diameter. So its diameter now is 50 millimeter. This is a very narrow one. We change it to be 50 millimeter. Very good. Here it fits our need, and it will control the flow of the water out of the air handling unit. And then the second controlling element we need to add is the balancing valve, which is used to set the pressure of the water inside the pipe to be at the required value to allow a stable movement of the water through the pipe. So let's add that pipe the same way from the pipe accessories. So we go to the system, and then mechanical equipment, and then pipe accessories, and load family, and the same thing, we go to the same path, and then valve, and then balancing valves, as we need a balancing valve, and those are some different balancing valves. So what we need now is a straight balancing valve. Here its diameter ranges from 15 to 50 millimeter. Then we press an open, and after that we need to put it inside our return pipe also. So we put it here at that position. Very good, that's about our balancing valve. Also, we can check its diameter. So if I select it and then go to its diameter, you can see it's set by default to P 50 millimeter. Very good. So as we said, the balancing valve is used to set the pressure and the water inside the pipe on the required value to allow a stable movement of the water inside the pipe. Now the next part we need to add is a gate valve, and the gate valve is a manual controlling valve that is used to control the flow rate of the water inside the pipe, so we can prevent the flow of the water totally using that gate valve, or we can control the flow of the water inside the valve partially to close it partially or to open it partially. And to add that gate valve, we do the same thing. We go to the pipe accessories, and then load family, and then libraries, and US metric, and then pipes. After that, valves. And then we search now for the gate valves. So we press on G. That's it. Those are the gate valves. And here the only gate valve we have is that gate valve. We select it and press it open. But now we will not add it on the return pipe, as we need to add it at the forward pipe here. So we add it at that position, for example, and that's it. So you can see that gate valve is connected to the output pipe of the pump, and the input pipe of the pump is connected to the output of the chiller. And for that reason, we are connecting now that gate valve to the supplying duct of the return duct. Now we can change also its diameter. So if I select it, here I find that its diameter is selected manually to be 50 millimeter. More than great. And finally, we need to add another element which is called the strainer. And the strainer is nothing but a filter that is used to filter the ingoing water from the chiller to the air handling unit as it filters it from the impurities that is carried by the water. So we need the water that enters the air handling unit to be free of the impurities, and for that we use that strainer as the filter. And to access that strainer, we go to the same way, the pipe accessories and load family, and then pipe. And now we will go to the accessories, and let's go down here. That's the strainer we need, which is the Y strainer, and it's called the Y strainer because its mechanical structure looks like the Y loader. Now we press on open to open it, and then we can paste it at that position here, and then we can paste it at that position here. So that's about the Y strainer, but it doesn't appear totally with its Y shape because it's installed horizontally here, and we need it to be installed vertically. So to see the full structure of the strainer we can select it, and we press on that loop here. You can see this is the upper part of the strainer, and at that part the water impurities are collected, while the water itself is going from the chiller to the air handling unit with no problem or with no impurities. And finally, we need to change its size. So if I select it and then we access it down, so we need its diameter to be about 50 millimeter, and the 50 millimeter is about 2 inches. So we select that 2 inches, and that's it. As you see, our strainer here has approximately the same diameter of the pipe that we have. So let's about this tutorial at which we have finished the operation of connecting the chiller system and making all the routing operation, and we connected the controlling elements that are used in our piping system.